of the rocks, the weathering of the soils and so on the moraines and the outwash plains and everything. So I'm kind of used to dealing with data that's not highly quantitative and semi-quantitative, we call it, to try to put the deposits in the right glaciation and so on. So I came with that. They came to this, from this beautiful scenery in Rocky Mountain National Park. I came nowhere. Let's see.
No, I can help you. Let me see. You want to go back
That's not working.
there?
What am I
Okay.
missing?
Okay, there we go. I'll do it from here otherwise. Is that good, or you want me to go in the other direction? Okay, sure.
Okay.
Oh, what is going on with this? Okay.
Oh, goodness. what
We
is
go.
nightmare.
There we go. Took a while to get here, but this is from the towers, looking at what I came into.
Wow.
As flat as a pancake. So what am I gonna do for research here? Well, I continued some of the Colorado research, but received an article in an education, geological education thing of a high school teacher who wrote in that he saw the topography of New England. This is Mount Washington in New Hampshire. And the topography of England was, of New England, was very much a result of what rocks were exposed and how fast they degraded. The guy's name is Perry Ron, and he got high school students on a field trip. And he said, well, let's, there we go, almost. Let's go look at a cemetery and see what the rates of the varying stones of New England are, because they're all there. The granite is very recent. Very recent. And that's lucky because it doesn't degrade at all. Out in Colorado, that would take like 300,000 years before the stone would disappear. So the granite, we're not worried about, but that's the highlands of the New England. And the schists and so on were second and a little lower. And then toward the bottom were the brownstones, of which many buildings in the Northeast are made. And then marble sitting in there, marble is a type of limestone, basically a pure version of limestone. I don't know why.
Sorry, the Zoom people can't see the slides moving for some reason. I don't know why, because they should be able to. Let me see.
My worst nightmare.
Yeah, no, you on this side, it's fine as the Zoom people for some reason. I think because it's not in PowerPoint mode, maybe that's why, but it should be showing them. Let me see, which is,
The Zoom people can't see it?
they can see it, but they're saying they're only seeing one slide, the first one. Ah, okay, this is the problem. Okay, just 1 second. I have to share the right one. Zoomers, hang in there, just a minute. Okay, this is good. Okay, now it should work.
Okay.
All right.
Great.
Okay.
Pause. I think it's because you're sharing, maybe.
Okay, now it should work. Now, is it working now or?
Yes.
Let me see. Okay, let me, otherwise I'll do it manually from here.
Okay. So,
Okay, there.
okay, what do I say next?
Can you, Zoomers, can you tell me if now you are seeing a tombstone which says weathering of a marble headstone? Yes, okay, they're back. We're in business, Tom. Go
Okay.
ahead. Okay, all right.
I'm gonna keep pressing.
Yeah.
So out of a textbook, this is a typical sort of geological textbook slide, where basically it's saying a marble headstone. You can read it yourself, but it's degraded. Obviously, you can see that in a cemetery somewhere. Whatever, that was the common thing. And it says in there that predominant mineral in marble is calcium carbonate and or calcite, and it's in a humid climate, so if it rains, you get degradation. So the problem was that nobody had ever quantified that. It's a real simple thing. We're not gonna look at any details of chemicals, but calcite, you add some water to it and it dissolves magically, and off it goes. Well, I wanted to see if I could quantify the rates of weathering on these stones, because that had not been done anywhere by anybody. Other than the glacier ones I'm talking about, where you can kind of see how fast it's weathering, there was, nobody knew. So I says, I'm gonna make myself a project here. And so I fished around in cemetery near us and looked at a lot of stones, felt a lot of stones. This kind of thing I found, looking at slabs of marble, and you can see that this particular one, I think, was in Wilmington, and you can kind of read the text, but it doesn't look that good, so something's going on here. And then I felt around, and this is something nobody had done, I think, down here at the bottom. It looks different, it feels different. It's the original polish from straight out of when the thing was polished in the shop. And I couldn't figure out why that happened, and I didn't need to. It's Mr. Graves' gravestone, which is, that's humor, sort of, in Tombstone humor. There we go. This is what's happening up close. See the calcite crystals, and they're falling off. They call it sugaring, because when it's on the ground, it looks like, pieces of sugar. And something must be going on to do that. And my thought was, okay, there's that dissolution. The only problem was, okay, so I ended up finding a lot of stones, and they all came out of one quarry in Vermont. And that's Sutherland Falls, they called it at the time. And it was all this fine grained marble. You saw how big the grains were, they were tiny. And then they would make these slabs and polish them as close to parallel on the two sides as they could, and send them off to the ultimate destination, which was by order. If you, basically you put the name and the date of death on at the end and of the line just before it's put into the cemetery. So what I thought I'd do is go down to the bottom, which has the original thickness of the stone, and measure it with a caliper, and then go up a certain amount, maybe a meter, maybe half a meter, I don't know which yet. And make another measurement, and so let's subtract one from the other, and then I know how fast the two faces are coming together through weathering. So you divide by two, because we only want to look at the precession rate of one side, and express, we know the dates on them, that's the good thing, the date of the death. So we know how long it's been out there to get what it's got. And so I said, I've got myself a method here. If those tombstones from marble have been spread around the country, and I'm gonna make a trip around the country, a transect anyway, just to show error. I had big calipers, and I went through a grid on a few stones in the local cemeteries, and notice that each stone, they have sort of a different, you kind of expect that the cutting might not be absolutely perfect, or they might be mounted upside down or downside up. You couldn't tell because they're so close to parallel surfaces. But this is without any real weathering except for one thing. Notice the numbers are, these are in millimeters per, excuse me, this is the thickness of the stone in centimeters, 6 centimeters. And you notice the numbers go down as you go up. And the same with all of these, no matter anything else, the numbers at the small were the original thickness of the stone against what you're measuring. But this shows me that there's a lot of variation. So in order to get some sense out of it, you have to measure. I picked a sample size of 30 stones. You do 30, you average them, you get one number for the cemetery, which is how fast this face disappeared. So went on this trip. And these are climograms. You all recognize this from introductory physical geography, the rainfall through the year and the temperature through the year. And you notice the temperatures on this transect that I made from the humid east and into the desert. The transect had the water levels going down. You can see by the time you get out to Winnemucca, Nevada. But the heat is about the same on all of them. So you kind of standardize one thing there. And that was the trip, which looks suspiciously like a freeway going out to the west, where my father lives in Reno, Nevada. So, or lives. So it was a convenience to go there. So if we look at the stones in the east, let's say Ohio, you notice you can barely see the inscriptions here, right? But you can kind of read them enough to tell when the date was. If they were much more weathered than this, well, have to make a guess. But I measured and measured and measured. Excuse me. This is Southwest. You can see what it's supposed to look like. So that's been out there more than 100 years at the time I took this picture. And it's easy to read. So I noticed that, given that, I might as well also record make a scale, which is how Harry Ron did this in New England. He asked the people to rate, what amount of difficulty it was to read the thing. And they're fresh up here. I'm sorry, I transferred you some slides to, you know what a slide is?
On back of any bond, Alexis.
So anyway, this was a 0, and then as you go along through this, you get down to the end where you can't read it at all, and you have to estimate the time by the nearby stones as to when the burial took place. But at any rate, so I could go out there and I could just look at this. This was an extra frill, just when you look at the stone and how legible does it look. And well, what happens is you have 0 here, no weathering, measured. Now you're comparing it to the measured stones over here, which the thickness and precession, and so on. And each of these dots represents a greater amount of weathering, and you can't, by the time you get down there, you really can't read the date at all. It's beyond. So I assigned these, this shows up later in the top. Indices. Now, the only problem was when I published this paper, and it was really popular because it showed an actual amount of how much rainfall dissolves the stones across a transect of water and lack of water. But just to kind of play with it, I got some acids and over a month poured them down the sink onto the marble and said, well, I want to see this dissolution work. And the only thing that was weird about it was that the stones they came this size, and I made them down to that size, but they never sugared. They never did that, giving off the little pieces. It was always structurally a sound piece, right down to the thinnest. So something was a little weird to me, but I thought, if I really want to make this good and, better than textbooks, what I should do is go to a place where they have more rain than Ohio does. And I thought maybe they carry these around the horn, these slabs, as ballast on ships and took them to Hawaii. Maybe that would be the case. So we headed to Hawaii on that basis. I didn't need a basis really, but anyway, this is the one I published. But this is Winnemucca, Nevada, mean annual precipitation. The axis should have gone here, but that's all right. And then the weathering rate down here, and it works out pretty well. This is the one that they like to publish in the geology books. So I said, let me see what happens, not just in Hawaii, but what happens if I get out here to Hawaii or Hilo 3 times as much rain. So I went to Hawaii, and there were 2 or 3 cemeteries, and they did take the Vermont marble slabs and took them off. And I thought, okay, these look pretty bad. Okay, except for one thing, these are just unclean. They've got mold on them. This is what they really look like when you clean them up. What would you give it? 0, 1, 2, something like that. And then I measured them with the bottom top measurement, and suddenly I started having to send letters out, and a form letter. And anybody that wanted to publish this in the geology book, I tell them, don't do that because it's wrong. Now, how often do scientists find their own error? But this is how science works, and I was lucky enough to find my own error. There's something else going on here than just plain dissolution. So I got in my car and went on a road trip, very long road trip. I I didn't measure this cemetery, it's out in the middle of nowhere, there are not enough bodies there, and they didn't get the right stone. But, the car was good for me, I put the back seat out, put a piece of plywood in, foam on it, and I'd sleep next to a cemetery, do the first thing in the morning, drive 100 miles. Do another one, these had all been predetermined by US Geological Survey, maps that show cemeteries within towns, the quadrangle maps. So this is eventually the sample spots that I got. The circle is real small, it's that there weren't many stones there. So there are over 100 cemeteries times 30 stones per cemetery times like 100 miles between. Now, the basis of this was it had to be a town of less than 10,000 people. If you were in the countryside, I was afraid that there wouldn't be enough stones. And so I looked for the city ones, but they're very small towns, really. And I wanted to say something about the West Coast too. This is the Winnemucca one. This is Yuma, I think, but I couldn't find cemeteries here. Well, I'll tell you what they look like. That's marble. And you can see it's not sugaring, it's done something entirely different and drastic. Anybody guess? I guess you can't see this, what's in the background, what's this? We're in the West Coast, Mediterranean climate. It's grass, but grass doesn't go well in the Mediterranean climate. What do? You sprinkle it.
Yeah.
All the cemeteries were sprinkled for the grass, and their stones were, that's a sandstone. The granite, of course, feathers at the front. So almost all of them were sprinkled, so I really couldn't get any samples out of the entire West Coast. Got one in Los Angeles that showed that the smog that they put out doesn't do much. The stones were in good shape. This is the map that came out of all those data points then, kind of crudely contoured. Out here in the desert, and even minus weathering, the only way you can have minus weathering is that in that sample of 20 or so, somewhere upside down and not quite parallel. But we see here northern Missouri and Pennsylvania, big amount. Now, big amounts in this mean like 2 or 3 millimeters. Okay, that's pretty small. This is not a big amount, but it is there. It's very clear. I didn't know what this meant, but that's what I was aiming for. I was adding geography to the equation here. Instead of doing a transect, let's get some geography, get it mapped, and see what that tells us. Well, I was searching through some obscure government anonymous literature, and just by chance in the library here, I happened to find this map. Does this look familiar from the last one? Should I go back and forth? But what is it? Is it Tombstone's damage? In which case I'd have wasted all my time. No, it is called accessibility to high sulfur coal. Okay, so this looks like a possibility. So out of a textbook, let's review our knowledge of coal. You have it already. If you're not a geologist, you might not. But the coal was where any of this is. It started as swamps, like the Okefenokee swamp or something of that sort. It's got carbon in it. It's also got sulfur in it. But then what happens is it gets filled over as sea level comes in and out, in and out. It gets pressure on it from the overlying layers that squeezes some of the sulfur out. And then if you mountain build in addition back here, excuse me for the, I keep wondering at the screen and I realize that those of you at home may not be able to hear me as I do this, but you know.
And this is pretty good, the mic, I think they can hear you well.
Okay.
This,
Good. So at any rate, they get squeezed more and more, and if there's mountain building, you get anthracite, it's almost pure carbon. And then they bituminous is these others, and lignite is like almost like peat, like they burn in Ireland or something of that sort. So this is the accessibility, and I don't know if you can see back here that it looks pretty similar. I mean, you don't want to pay a lot for your coal because it's not worth that much, and so you don't take it very far, and so that's where the accessibility comes in. And the damage to the tombstone. So we can assume that the damage being done by me. What did they do? Go forward on that one.
It's not working, okay, yeah, there we go.
Okay, so start being a team effort, and I almost said tombstone effort. With Lisa Botluck was a student here, and she wanted a little credit. She was short like a quarter credit or something, and one of the projects, so I says, well, go out and measure some tombstones, and what she did is take a caliper in 3 different spots, Philadelphia, Wilmington, Newark, and 30, each dot is 30 samples. And see what the shape of this thing that I've been measuring, this is the fresh polished surface. This is the weathering inland. We can see a difference between the different towns or city. And that's pretty neat, but also what it shows is that whether you measured a short stone, you take a caliper measurement off the ground a short ways or a long ways, it's basically what you get the same result. So you can kind of expand the rate of what the places that you can measure the rate. But the other thing was the difference between them, and she was done with her work. That was fine. I appreciate it. But then there was Johann Fedema. He was in this department and he was well liked. He's a good friend of mine. I think deceased now. And he was chair out at Lincoln, Nebraska, I think, in the geography department. But he had Dan Leathers isn't here, but I think he had one of Dan Leathers' courses. And he says, Lisa, that looks like, that looks like wind curve close to the ground in a microclimatological way. Wind doesn't travel very fast at the ground. And if there's something in the way, nothing in the way here. If there's something in the way, the air sort of goes around it and there's no turbulence to mix in whatever chemicals are in the air into the stone. There's a layer around you. You have it going on right here, a layer around you that is not moving. So the pollutants have to get through that boundary layer to get to the stone in order to add their chemicals to the stone. Don't worry about the details of this, but so Johann decided he was going to do a master's thesis, and it's right down there in the main entrance space on the main office. And you can look up this, but what this is Delaware, Philadelphia, and residential sort of and heavy duty residential. And along the Delaware River and Toolsville River, there were all these different kinds of things that were burning coal. They started off burning coal to make railroads run. You see old pictures of the steam coming out of the pipes, the ash coming out of the pipes. But the good quality coal got used up, and they started using more high sulfur coal to make the incinerators work, the refineries, the electric power generators when electricity finally did come in, and so on. Next. Thank you.
No, okay.
Okay, so each of these is a cemetery, each dot. And this is what it was. Here we are down in North Delaware with very little weathering. And in 3 millimeters or so in central Philadelphia. So that's a pretty important gradient, very close gradient of having practically, could breathe easily here. And there, you probably get asthma and so on from all the, partly because the population was burning coal to be warm. I don't know if you've ever seen a coal chute in somebody's house, but all the houses had them back then. Oh, sorry, okay. Johann looked inside the stone with scanning electron microscope views to see what a calcite grain looked like down at the bottom of the stone. It was not too hard to get these stones. We didn't tear any down to sample, but they have a discard pile in some of these cemeteries where the stone just couldn't support itself, fell over, so we could get it. And I'll look at it. And this is the top part of the stone in Philadelphia. I don't know if you can see it different, the calcite grain is the same scale as the last one, but there's all these little things. And what are they? And I don't want to bother you too much, except for say calcium carbonate does some things when you have some humidity, rain and so on. It gets down here and forms gypsum. Gypsum in the dry walls here, there's gypsum, it's all around us really. But the gypsum thing was that the volume, it took up a lot of space, 38% more space than the calcite. So think of these little crystals growing in between the grains and knocking them off to sugar them. Or even worse than that. We did some worse things in Philadelphia and we were mixed up, he and I. We think we were doing all good Vermont marble, but there turned out to be a marble quarry in Philadelphia and all the old stones came out of that. And it was a very inferior, very porous marble compared to the Vermont one. So just a little aside here, you can see from a side view, there's a slab, but you can't see that. But you are seeing that the edge is coming off. So something happened here to this inferior stone, which is quite porous, and you start looking at thin sections, which the geologists know about. Couldn't photograph one, so he hand drew it. Of one of these stones that was exfoliating, that is getting rid of this outer layer. You can see there's almost no gypsum. The gypsum is black. There's almost no gypsum in that layer. What happens is you pull out a stone out of a quarry and it's wet. And so they let the thing out in the sun for maybe 2 or 3 years before they could give it away. So what would happen is the moisture would go.
Ensemble data.
on the edges.
Interesting service we're gonna have under conflict.
Who was that? Oh, sorry, please mute.
So anyway, there's hardly any gypsum in that. It's a strong layer. It's called case hardening in geology. And what's happening is then all the air with the water vapor and the gypsum can get in there and start forcing all of the interior of the stone outward. But the hard part that's so reprecipitated does all right. Johan got that and he measured the amount of that happening, but the way he had to do it was a different index now, semi-quantitative index. That was to say that we're gonna look at a stone and these things were falling off or exfoliating their outer surfaces and make an estimate of it. I'll show you the estimate in a minute. But he looked for the old stones that were there with that exfoliation going on and estimated how much exfoliation is there in terms of a percent of the
What?
You're muting people. I'm just muting people who are not muted, so we don't get that. Sorry, just 1 second. Okay, there we go.
Anyway, there it is. Okay, who wants to make an estimate? How much percentage of the face has been lost? Off the stone? 100%? 70%, okay, I see some text down here, so it's this. So I give it like 30%, something like that, but if you do this enough, make the estimate, you can't use the calipers on this because you got that big side of the thing falling off, so it's a really poor thing, but you estimate 30 and you get a sense of how much they're losing. That brought up another interesting, soon to be seen, sorry.
Let's see, there we go.
Would you want me to control that? Or?
No
Okay.
problem. I can take care of it also because I'm managing.
Okay.
Those start.
Okay, this is an interesting thing that happened there in the downtown of Philadelphia where all that weathering was going on. Johan looked at a picture, historic picture. The stone was laid out 1788. And the picture was taken in 1905. How does it look? What's your estimate of the legibility?
Very good.
It's pretty good. So that inferior stone was out there for more than 100 years before this photo was taken, and it's in good shape. So he found a number of photos. This is the same stone when he went out to measure it in 1990s or thereabouts. So almost all of it's gone, same with the, so what happened here? That what I'm gonna show here is a little hard to figure out, because I got two lines here, but somebody made an estimate over time from 1880 to 1980 of how much sulfur dioxide should be put out, how much of the sulfur stuff should be put out, depending on population, who uses coal, what type of coal. And he did this on 10 years intervals and industries and so on. Fred Liebert was his name. And he did this and calculated the peak of that coal was about 1940 for World War I, World War II, because there was all this machinery going on and people in the north needed to keep warm at the same time. So then we began to see the social aspect of it. This is the output. These are those photos that were fine until this blob of weathering material, polluted material comes in. And then starts taking off. So the same thing, you look at a stone taken in 1950 or 60, and it doesn't look so good anymore compared to 1990 or so. And in other words, there's a lag time between the time this blob of a pollutant comes in, attacks the stones, and this just keeps going up and up as you add more and more pollutant to the stone. So this was Liebert's thing. I won't bother you too much with it, but heating degrees day, if it's cold, you use coal. Down south, they didn't use coal for heating because it's warm. And industrial and all these were estimated. This is a model. Well, he made. Excellent. Thank you. He made estimates. This was, sorry, the names didn't get on these, but there's are 18 cities in the United States, Eastern United States, that he made estimates for, and I think this is a work of some genius. Each of these is 1880 to 1980, and it's showing how much pollutant is hitting those stones in these different American cities. But he's got a hypothetical model here. How does he know it's true? Well, we go out to all those cities and measure how weathered the stones are and use that as a check. So we're working back and forth. We use their blob to say when it happened and our data to say how much it happened. And so this is a typical example. This is Cincinnati, Ohio, and kind of contoured it in. So 2.38 millimeters in the center city. And so that's what that city got. 30 stones per sample, and there were about 10 samples there, 10 places. Well, this is how it worked out. This is a piece of dust that got on the slide that I came through these off of. So don't count that. But you see a nice, the more the city got in pollutant, the more the stones fell apart. That seems logical, but nobody knew it. So these are all pretty kind of new concepts. Then comes Kathy Valamont Schreiber, who also has a master's thesis down in the main office. And she was familiar with Western Pennsylvania, which is one of the high points of getting sulfur dioxide gas. And she knew that it had a lot of cemeteries in it. In fact, it's probably the best place on earth to do our method. We're looking for the granular weathering of marble tombstones that were imported out there like crazy all over the environment. And this was, okay, this is Pennsylvania. She did a very small area, but had more than 100 cemeteries with enough tombstones to measure. Pittsburgh sits around here. Of course, Pittsburgh is on the intersection of different rivers to bring in iron ores, bring in polluting coal. They're no longer using the good coal, the anthracite, they're using bituminous. And it's also, so this was a main manufacturing place in the United States. Now I apologize to her, well, this is what it would look like with smoke coming out of the stacks in Pittsburgh and all the other places too. So imagine living in that. The same sort of thing happened up in New York City. They had very high amounts of manufacturing as well, all kinds of manufacturing things being made. They used to be made with water power, then they're made with coal heating in this case. People up in New York were getting that too, and the rich ones that are making all the money off the manufacturing took all their houses to Newport Beach. You know, they had vacations there, Newport, Rhode Island, and all the mansions and everything, because they wanted to get away from this smoke that was constant from people burning it in their houses and so on. So, this was a mill up in the Northeast. I wanted one over in her place, but there were a lot of paintings made of mills with trains, and this looked just great industry, things are going well. And people who lived there, in spite of this thick fog, like the London fog was the same thing. So this thick fog was there, and they probably had all kinds of medical problems, asthma being probably the worst. But in some cases, people were dying from all the smoke, but they have these pretty pictures showing that the rise of industry and the industrial revolution is here. And the rich people escape it to the beach. Okay, well, this is terrible because she has an absolutely great graph in her thing, which I couldn't get into the machine here. But this is, let's show you myself. This is an early try at visualizing this, but these are the cemeteries in her area, about 50 by 50 miles, something like that. Lots of cemeteries. This is Pittsburgh, this is Johnstown, this is Altoona, Clearfield. But there are these little blips, and every one of these is a mill. The people loved it because there was employment. They didn't mind the smoke because they were employed. So anyway, this is where the rivers come together. The mills were all along rivers. And I kind of wondered as I'm looking back on this, if you were working in here, if you could just somehow go home at night and to breathe fresh air for, this is tombstone degradation, but it's telling us how, it's a dosimeter is the word for it now, a dosimeter of how much total pollutant that place got. Well, a couple other things. One is that geological books, textbooks still go along, and art historians still go along with the idea that dissolution is what's happening to the stones and the statues and everything, dissolving from acid rain. This precedes acid rain. But what I wanted to look at was, if we're looking at dissolution, what we'd like to look at is not a vertical slab. We'd like to look at something laying out flat that captures all the rainfall coming down equally. So this is cemeteries in the Philadelphia region, looking at ones that were on the ground. They didn't just make vertical slabs in Philadelphia, they also had them at ground level. And you find that in some old cemeteries with the bad marble. At any rate, what this should show is that there was a lot of acid rain. Wouldn't you think with all those pollutants coming in, there'd be acid rain that would dissolve the stone? How does that look? What's the estimate on the scale? 3, something like that. And then you use the transference function to find out how much that weathering is, and it isn't a lot. Let's go up right next to it. One that's 4 feet off the ground, and it was also horizontal. Does this suggest you're having acid rain, or does it have kind of more dry stuff blowing in? So I don't know if you understand this concept or not, but this is doing what the marble stones were. Well, nothing at the ground, but if you're raining on it, it should all get an equal amount and be equally weathered, and it's I'm gonna pass on that one. So just to get that point through, there was a nice little case in Chicago, which also had a big manufacturing base and a lot of coal burning. Somehow the Carrara marble, which is a great marble for sculpture from Italy. Whoever did this really wanted to preserve this statue of this little girl. And she's totally encased, top and bottom. And in glass, and she looks in perfect condition. But this one, for some reason, the owner, face is great, legs are really not looking good at all. And what happened was they drilled about 12 holes in the base. I guess they wanted fresh air coming in and out, and instead let in the bottom, let the polluted air come in. And just to compare that to Carrara marble statue in the outside sculpture, I think you can see even from the back of the room that that one is not doing well. Well, okay, so we're coming to the end of Leeper's blog there, and they're talking about what the different sources are. But by 1982, basically everybody stopped using coal and not getting any more coal in. But of course, for the stones that are like that statue, they can't go with the curve and say, okay, there's no more pollution, so let me go back to being new again. You don't go back. So I guess you can get that. So, but the end of that era was partly presaged by the fact that they started making power plants, and now you could get electricity in your home, not coal burning. And keep warm. This tower down in Georgia is about 1,000 feet tall, and they built them this way to say that we're going to burn that high sulfur coal in here. But first off, we're going to scrub it. And what do they scrub it with? They've got to get it to react to something. They grind up limestone and marble, and they feed it into the bottom of the pipe, and so it neutralizes everything right down there. You get all the marble weathering going on right within the pipe. That's a scrubber. Second thing is the height. Unlike electricity plants from the earlier times, which were low to the ground, 100 feet off the ground, they had these 1,000-foot ones, and the idea was the solution to pollution is dilution. So that air at altitude is going to move way downstream. Where does it go? To the northeast United States, has slightly acid rain. But I wondered when I was out in Georgia, I specifically went for this. What does it look like down here? Is it doing a good job of getting the sulfur that they're burning? Is it going to affect the stones nearby or not? What do you think? They plot these electricity plants down in small towns, way out in the countryside that had no weathering. And then they've been operating now for 50 years or so. What do you think? What do you think? Okay, pretty good, right? Almost zero. So in other words, that cemetery had received no pollutant, including the electric power plant. Just a few other little details to start using these marble stones was to go to Colorado, go up in the mountains. So you see I shipped a lot of these marble stones from Vermont out there. But what I was going to investigate is frost weathering. The geological journals and the art historians say, well, here where we live in Newark, Delaware, and so on, there's a lot of frost. Maybe not so much as up in Maine, but there's frost and it breaks the rocks and it breaks the buildings and everything like that. So let's check it out, see how frost weathering does. So we go up the mountains. This one in the central city, go to geology, geography of Colorado. This is Leadville, Colorado, which is approximately the highest town in the United States at almost 11,000 feet, roughly. It's on the boundary of the forest versus the tundra up above it. So I went there and says, if you're going to find the weathering of that intense sort of ice weathering, ice grows in the cracks and should tear the stones apart. Looked good. Looked good. But I went to Silverton, Colorado, almost same elevation. What does that look like? So where's the ice weathering? Well, I went back to Leadville. It turns out it was the smelter center of the Rocky Mountains. So they were putting all the air pollution in the air to ruin the stones within their cemetery is decimated for Mormon. Another little thing to do is, these are side projects with individual articles separating. This is Yale University, it's made of brownstone, and brownstone is a sandstone, an Arcos sandstone, with iron that makes it brown, and people love it in New York, you hear about it all the time, and Philadelphia. And the historians are saying, well, this is being affected greatly by the pollution, by the sulfur. So I did a thing all over New England, going to cemeteries, had both stones in them, and found out how weathered they were. Since this one looks exfoliating, I had to use an estimation amount lost as a surrogate for real measurement. But point was that when I mapped them, and I can't seem to find the map, but when I mapped them side by side in the same cemeteries, the marble stones and the brown stones, there was no correlation. There was so in other words, I'm using the marble as a dosimeter of what was there. And this stone did not, I don't know what it does react with, but it isn't sulfur pollution. On leaving off on this one, I am done, and I'm just leaving this for contemplation. Something when I got the call to come in here and give a talk, I suddenly started thinking about this all again. And really appreciating that we had a big catastrophe throughout this region, which was the burning of coal that caused human health to deteriorate, and as well as the marble. And I was contemplating whether there was any way to go back in history and find out who was sickest the most and where. The geography of sickness for people that lived in that age, but I think it's too late now to do that study. I appreciate you coming. I appreciate.
Thank you very much indeed. This is amazing. You know, for our students, especially who are in person and online, you know, your presentation is so rewarding in multiple ways. First of all, in terms of the methods that you utilized, you know, we are so pampered in terms of the kind of fieldwork tools we have at our disposal, the computational tools, and for you to do this kind of almost like an investigative, you know, mystery research enterprise with those tools is just amazing. And this is also the research showcases the beauty of geography as a field, because you are doing the empirical work, you're looking at the chemical aspects, but you're also looking at these other big picture spatial patterns, trying to see where there's overlay. And so it's just marvelous. And I do hope the students appreciated all those aspects of the work. So let's open it up to questions. We have 20 people online, and we have just about the same in person. So please take it away. Zoomers, you're welcome to either take the floor and shout out a question, or you're also able to chat and put them in the chat. So first from the participants here, Peter.
I knew it would be you.
No, I knew about your work, obviously, because I was sort of living around it. But it was really refreshing to hear it all over again, and in a condensed form, because really you've condensed an enormous amount of time into a 40-minute presentation about all this work. But without being immodest, to what extent do you feel what you did was so unique? Because how many cemeteries roughly did you visit in the course of all this research?
Around the United States was about 8,000.
8,000.
8,000
Now,
And there was cities and.
okay, so 8,000 times 30 stones. Okay, so that,
Oh, I'm sorry, you said stones. No,
well, I said cemeteries, but then you get
cemetery.
30 stones
Okay,
per
I'm sorry.
cemetery,
No,
more or less.
cemeteries was more like 120.
All right, okay, even worse. So what I'm getting at is, how many people during the time that you were doing research would have replicated your work. I mean, a lot of science is based on replication, right?
Mhm.
And so I would assume that probably the answer to that question is no one. So to what extent you are almost unique in your work and your finding. So as I say, don't be immodest. Tell me, what impact has that work had on the broader area of science that you worked in geomorphology? Do you think?
I'm not sure that it has a big impact on geomorphology, because I'm not measuring out in the field how fast the surfaces are degrading. I'm not sure how it affects the field of geomorphology. I can't answer the question, I'm sorry, Peter.
Well, it sounds like, I mean, your impact clearly was in terms of also the role of, you know, the air quality regulations which were coming out around that time. What could be the impact of those? Like you, I mean, I could see some of our students now going and doing the research, now that we've had the Clean Air Act for so many years, and seeing what's happening now. People don't use tombstones as much anymore. They're cremating people, but they're still, I mean, there are people who do. So that would be amazing. I think that's a really important impact too, to be able to validate. And especially that Leadville example is fascinating. I know Sandy's been to Leadville. I've been to Leadville. It was featured in one of my books, and I can see the it's
You're
compared.
probably aware that Leadville had this history, but I wasn't. I was surprised.
Yeah.
Thank you for saying that. You can answer all my questions.
No, absolutely. But it's really impactful in that way. And I think it's a great opportunity for our students to see if they can use some of your past data, compare it to now, and do a longitudinal study, you know.
I was just gonna say, this is not an answer to your question, but I was thinking about this as I went along, that I love to travel. I'm a geographer. I love to go to different places. And so for me, it was an opportunity. A lot of those places out in the Midwest are fairly boring, flatter than Delaware. But I love doing it, and I do have sort of an anecdote here that I can't resist. I have been asked back in the days when I was doing this, whether it was lawful to be walking on people's graves and so on, and a creepy feeling. And that took me about a week to get over. But not to be sacrilegious or anything, but my measurements were non-destructive and so on. But I went to all these places. Some of them I took my family along. Now, here's where it comes in. Was I treated as an unlawful person within the cemeteries? But I was arrested. My family, for my 80th birthday, got a house up for everybody to stay in up in Cape Cod, but they said they're gonna give you a surprise for your birthday. I don't know what it was. So as Fern and I got off the train in Back Bay Station in Boston, where my daughter lived, we were walking out with our bags, and suddenly somebody just ripped the bags out of my hand and so on. And I turned around, and there's security people with dark glasses and said, "You're under arrest." And they gave me handcuffs and handcuffs and dragged us out to a black car. It took me just about 10 seconds to recognize that it was my own family dressed up as security. And they took us to a jail, penitentiary. The penitentiary had been turned into a hotel, but it still had all the jail bars and everything. And we were booked and photographed and everything. And everybody played their part the whole way through. And I kept asking, well, what's the charge? And they said, child abuse. You took us to way too many cemeteries.
Wow. What a fun family.
I hope he's a cardiologist here.
Okay, wonderful. Other questions? Yes, please.
Can I just add some comments?
Yes,
So-
please.
When I came in, Tom, just a little side, you were doing all the cartography. But Tom was doing all the cartography, and Lillian will remember all this in terms of the old cartography, in terms of the dark room. And the dark room was back there. And so he was teaching everybody how to draw maps, you know, in terms of pen and paper. and shown how to do the photography.
Wow.
But also Tom was known for his courses in terms of the beautiful photography that he showed. And so he brought so many students in with all the beautiful pictures he showed. And also during our big convocations, when we had it just our department, the beautiful pictures that you would show during our convocation. So thank you for that, because that was always something I always remembered in terms of the beautiful pictures. And I know you spent a lot of time doing those during our convocations in terms of our celebrations, those beautiful pictures that you showed us. So thank you for, just as a.
She's referring to really things I just saw as I was traveling, so it was.
I know, but still, you used to put beautiful pictures, and I would remember the students saying in terms of your courses, all the pictures that you showed, because I think those pictures were illustrative of everything you showed. And, you know, thinking about those slides you showed going the whole way across the country, because those are in many cases, a lot of things that I have not seen in my research in terms of things, so. Just a little aside.
Thank you, Tracy, I appreciate it.
And I think we have a few, Corinne has two questions, one of our PhD students as well. And Corinne says, in your recollection, how much do you think worries about cemeteries, monuments, limestone buildings, etc., disintegrating were a catalyst for air pollution regulations in the policy world?
I had no way of knowing that, or even thinking about it. I'm sorry to say.
Was there any media coverage of your work that was picked up by like legislators or?
There was.
Oh,
Good
okay.
point. I forgot about that.
Okay, great.
I was even in the National Geographic with 2 column inches.
Wow, that's great. There you go, Corinne.
Yeah,
What-
there was a lot. But actually, strangely enough, I think now that things have gotten better, we've forgotten, this is now becoming forgotten history of something of this catastrophe that traveled through time. It's over. And so when I looked up, you know, on an intelligence thing, you know, what's destroying the marble stones, these intelligence programs, and it said dilution, dissolution, dissolving of things, and ice, pretty much, and they've forgotten all the rest. So I think that you're right, that a huge change was made, but I wasn't looking at the politics of the regulations at the time.
Yeah.
The other thing is that you can go to the cemeteries now and they're still gonna look weathered. They don't go back to zero.
Yeah.
Input.
But
So
no
I
doubt.
am not answering the question. I apologize, but
No, I'm sure you had an
I didn't
impact,
think about
because if it was in National Geographic, and, you know, I'm sure people were using that kind of work and cultural heritage sites as well. And then she says, I love this talk, which won't surprise faculty here, and I highly recommend the book When Smoke Ran Like Water by Deborah Davis.
okay,
Yeah,
you're gonna need to write that down.
yeah, yep, by Deborah
Thank you.
Davis. So, and Corinne's research, Corinne, you're welcome to also take the audio, but she's working also in areas with smelting in Quebec, and you know, looking at it from other points, but in Quebec area, more so like near the Noranda and that area. So
Great,
yeah.
thank you.
Okay, and then Kathleen is saying, I agree with the wonderful pictures in the courses. Made the point and really brought interest and beauty to the material. So echoing Tracy's comment.
Is that
Kathleen Schreiber.
she?
Yes.
A picture in Latin.
Ah,
Picture
yes.
we saw.
Kathleen, you would like to take
Thank
the
you.
audio if you're welcome to say any words of greetings to Tom.
Don't say I stole your stuff.
Hello, everyone. I
Hi.
wanted to thank Tom for turning me on to such a great thesis topic. It was a fun topic and a meaningful topic, and I just really enjoyed all that work with Tom. So thank you, Tom, for that.
Well, thank you for the kind comments, and your study still is the best of them. Mine was the wrong scale, where you had 100 cemeteries, I had 1 dot. One cemetery.
You set me up for that. You all set me up for that.
Okay, good to see you.
Great. And Tina Callahan is asking a question and raised it. Tina, you have the floor.
Thanks, Elaine. Hi, Tom, it's Tina Callahan. You probably don't remember me, but I was Purcell at that point for my maiden name. But I first have to, second, third, what's already been said. The work that you did in helping to share the stories was actually very inspirational. I have to say, as an undergraduate, sometimes it was a little hard to stay awake in the 8 a.m. class with the dark room with the slides, but they were really awesome and beautiful and a lot of very inspirational. But the second part, which I'm not sure if was really being able to be seen during the slides or the slideshow that you were showing today, but the mapping elements that you were able to teach and share. And it's not just the mapping, but the detail that was really, really so important was something that came out in all of your courses and all of the things that you shared. It always had to go in multiple levels, you know, in the terms of the first, we got to get an idea of what we're sharing, but the detail of what I learned on how to map by hand, the information, and to be so exact with the information and being able to do that with my hand just gave me such an appreciation for that next level when we went into the digital world of making the maps. And so I guess I just want to say, like, I know I have harkened back to my days and mentioned you many, many times when I've had to talk about my GIS work, because oftentimes it really needs to be focused on what is the reason for the map and how is it created, and to really realize what kind of work went into all these historical maps to make them as accurate as possible. So that was my one comment.
That is a great comment. I appreciate it very much.
And the second, go ahead.
Right. It brings up another thing that you mentioned, the digital age. Cartography became really hard to teach in the digital age because the programs, you needed a different program for each kind of map, and there are so many different kinds of maps. And you have to keep up with that technology for teaching it to expose students to all the different types of maps, but at the same time, so that at the same time as the programs were changing, they were constantly changing it at the university, whether you could print or what it was a nightmare to teach the digital cartography as compared to pen and ink. So, but thank you for.
Yeah, the second thing I did have was kind of a silly question, but I've seen some influencers on YouTube that actually have gone out and gone to the tombstones, and they felt they were doing you know, a good thing to kind of help scrub the tombstones down because you can't read them. And so I've thought about you because I thought, I wonder what Tom would say about this, you know, because they're going in and trying to clean off all of the mucky muck that's on there so that you can read them. Anyways, I'm just wondering if you had a reaction to that.
Well, sort of. I appreciate them doing that. Tombstones and cemeteries really have a cultural, we have a cultural need for these things. The only history that some people are going to get in their life is on their tombstone, their headstone, and reading it is important. The problem is you can't put back what was done by cleaning them. And the other thing I might point out was, do you notice the picture of a stone in Hawaii? It had mold all over it, but was otherwise beautiful. Now, if they cleaned that off, they'd see the beautiful printing underneath it. But the problem is, if the tombstone is black, that probably means there was no acid rain hitting it, because the acid removed that. So if you see a black stone, it's probably, you go ahead and clean it, but the reason the black is there is probably because it never had the sulfur to begin with. I don't know if that makes sense or not.
Oh,
No.
that's great. Thank you for sharing that.
Black stone is the opposite of weathering.
That's great. Yeah. And there's a comment from John. He says the area of Palmerton, Pennsylvania was seriously impacted by zinc smelting and is now recovering. This could be a good local study area. So there we go. Maybe some of our students and faculty might look into that as well. So
That's interesting. And
Palmerton, yeah, I don't know which part of PA that is. Palmerton, is it central? I don't know.
my
Yeah.
guess is that Kathleen would know.
Yeah, yeah. Okay, great. Any other last minute question? We have 5 minutes or so. Any thoughts on Nancy?
This is the first question, your thought, like, what prompted this study? Like, and it was one question, and then maybe assuming that it might have something to do with like human health and maybe if the stones are disintegrating, what's it doing? If you were gonna map, like, maybe just one or two diseases or human inflicted ailments connected, which two might you map?
Ooh, this is kind of what I was lamenting at the end of it. I never got into the human health issues. I went out to do my work with blindfolds on, blinders on, and I just did the measurements and I wasn't thinking about the human health implications, I'm sorry to say.
So how did you choose this?
Okay, to summarize what I talked about first was, I was interested in landforms and landform evolution. How long does it take for things to get worn down? Well, nobody had any numbers on it. So at the rate at which this occurred. So I was trying to be the first one to find how fast the surface was receding. And that was for geomorphological purposes. It turned out to go in a different direction than I didn't know it was going to go. Which is maybe a tale in itself. You never can tell where you're headed and how you're going to diverge. And I like that Yogi Berra comment. He was a famous comedian, baseball player. He said, if you come to a fork in the road, take it. So I was in many forks and ended up in a completely different place, but only today am I thinking I should have got into the medical aspect as well.
And that's actually a new, relatively new area in geography called geohealth that is taken on currency. And we have one PhD student who is working on geohealth, but is working on schistosomiasis, on communicable diseases, but looking at it from the point of view of water, management and so on. So, wonderful. Okay, I think we're right at the mark for time. So thank you so much, Tom, for enriching us and this. Thank you to the Zoom audience. Lots of claps on Zoom, virtual claps going for you as well.
Appreciate you having me. This has caused me to come out of my